Hello, everybody, and welcome to the Public Safety Summit here at Coptrz. My name is Sam Denniff. I'm the Business Development Manager for Public Safety and Defence. Here with us today for this, the final webinar of the 2 days of Coptrz. We have Randall from Flir joining us from the US, and we have Nick joining us from Northamptonshire Search and Rescue. So, two different sides to the sort of public safety side. We've got a manufacturer developing the equipment, and then we've got one of the users on the ground actually operating the kit. So what we're going to do is we're going to get Nick and Randall to describe a little bit about, firstly on Nick's side, what he does with drones, why they decided to look at using them, and the benefits they give. And then from Randall, it's going to be great to get an idea of what Flir are looking at developing in the future, what they've got out there at the moment, and you know, a bit more of a detail on thermal cameras and thermal drones in general. And then throughout, if anyone's got any questions, fire them into the chat, fire them into the questions section on the side there. We'll interject and run through them at the time. Randall, if you've got any questions for Nick during his part of presentation, feel free to fire away. Nick, vice versa, any questions, send them across to Randall. So before we get into your presentation, Nick, do you want to just introduce who you are, introduce your search and rescue team, and then feel free to start running us through your presentation.
Brilliant. Yeah, thank you very much, Sam, and good afternoon, everybody. Firstly, I'll just apologise. I'm sat in the car. I had great plans of being in my office at home, but at 11 o'clock this morning, we actually had a call out. So deployed about an hour away to search for a high-risk missing person, which I can confirm we did find with the drone. So quite pleased with that. But a bit of background. So I'm Nick. I'm a Lowland rescue pilot. My team's Northamptonshire Search and Rescue, and we look for high-risk missing people. We can only be deployed by the police, so quite often it's really difficult for us to talk about what we do in the public domain. So on that sort of background, we don't really have much sort of marketing to show, sort of like a sister organisation like Mountain Rescue. A lot of their things are in the public domain and they can talk about it, but mainly it's high-risk missing people in terms of dementia, suicide risks, things like that. Based in Northamptonshire, we haven't been around for many years. I think we're into our 7th year now, and what I'll do is I'll basically run in through a quick PowerPoint presentation just to sort of give you an overview of what we do. Bear with me 2 seconds, which hopefully it's going to work out when we get going, just so you've all got a clue. So it's always easier when you're in an office. Never mind. So who are we? So where Lowland Rescue sort of fits in, a lot of you will have heard of Mountain Rescue, Cave Rescue, the RNLI, but just as a bit of a sort of, so you're aware, we do everything from water to high hill pretty much. So we fit into the middle of that quite nicely. We have a lot of the same standards as our sort of partner organisations. As I say, we work quite closely with the police. In terms of statistics, these were released last week, actually, so they're quite relevant for last year, for 2020. As you can see, the main one at the top there is that we currently have 46 drones within the organisation, varying different levels, some with thermal, some without. Our one that we took delivery of literally last week is one of the thermal drones. We are completely volunteers. So we don't have any sort of government funding. It's all shaking tins or donations that come in that buy our vehicles, buy our drones, that sort of thing as well. In terms of a bit of a background with drones, this is a bit more me personally rather than the team, but just so it gives you an idea of why drones really is, you know, I started back in 2013. My everyday role is in agriculture, so flying fields, that sort of thing. Starts off with a Phantom, quickly moved to a bespoke drone that, looking back, was a complete waste of money, and then moved very quickly into something like the Mavic, which just revolutionized for me and for our team the world of drones. And we're currently running some Mavic Pro 2s and quite quickly going to be upgrading those in the near future, to which hopefully be talking to Sam about. But how our team works, predominantly we're boots on the ground, and we are looking for people in any sort of rural areas as well as urban areas. We do have searched dogs as well, and we also have swift water teams. So we do, in Northamptonshire, we have a lot of waterways. Even though we're completely landlocked, we do have a lot of inland waterways. And been a dream of mine for the last 3 years to have a drone as part of that. And as I say, last week we finally took delivery of our Mavic 2 Enterprise, the brand new drone. I think there's only 8 or 9 in the country. Very lucky to have got one of those quite early on. As I say, we deployed today for the first time on a live job. Most of you have probably seen marketing pictures. This is what we're flying with now. In terms of our training, we've got 4 A2 pilots, which Coptrz quite kindly helped us get everybody qualified. And once we've done that, we then also have a Lowland Rescue qualification that we have to achieve before we can fly, purely so that we are searching fields and areas in the right way to a standard which runs along the same lines as what the police sort of standard is with using those drones. In terms of the kit for us, they are small, they're lightweight, they fit into a backpack, so we can take some of this kit out and we can carry it on us and use it as an asset. So we might be a foot team that then sees something that we might deploy the drone to, instead of traveling out there in a vehicle and purely being a drone team. So we've got different variations that we can sort of set this up for. In terms of the actual smart controller, some of you may have seen this, some of you may not, but the quality and the digital zoom ability of it's fantastic. On the controller there, that white car in next to the container is actually 1 kilometre away, and we could, a few more zoom levels, we could actually almost read the number plate, so we're quite impressed with that, which for us, if we're trying to identify a person, is really handy in particular. And with the thermal mode, you've got lots of different color settings you can set it on. But again, it's 4x thermal zoom, and you can pick up heat sources. You could be 60 meters up in the sky and you're picking up the heat source of a rabbit that's in a woodland. So for us, we're looking for a body or a human-sized object, not rabbits, but the fact we could pick up rabbits, hares, deer, that sort of thing, just shows how phenomenal this is. The team we were with searching today, they have the old version of this, and the difference between the thermal imaging camera on theirs and ours is just leagues apart. But I say Sam will have all the sort of the technical detail and information on that. One thing we do differently to some sort of industries is we always have a spotter, so that the pilot can concentrate on searching and then the spotter's looking for everything else that's going on. And that's pretty much how we run as a team. We deploy as a team of 2. So that's my sort of presentation. That's the sort of the quick introduction. I think I was promised 5-10 minutes, so I think I'm about time. So I'll go back to you, Sam. Thank you.
Yeah, that was spot on, Nick. That was a really good as a brief introduction. You've hit all the points there pretty well, I'd say. One thing I was hoping to find out a bit more on is and you mentioned it there, the traditional methods that you guys use, and whether drones are replacing those, whether they're just augmenting, adding to them. So stuff like the dogs teams, for example, do you use the drones alongside those methods to make them more effective, or are they replacing them?
Yeah, so we still have the risk that we can't fly in high winds and we can't fly in rain, but we're needed 24 hours a day, 7 days a week. So in those situations, the dogs will still, and the feet on the ground will still have a massive priority, part to play. We with the training we've got in place, we're all designed to work alongside each other. And so if we get a find with a drone, we won't go to the person. We radio into a foot team, and the foot team go into the person, because they'll normally be carrying more equipment and things like that. So we'll never be a long way from other people. With the dog team, we try not to go places where we'll leave a scent to confuse the dog. So if we can fly the drone over first, get an overview of what's going on, and then the dog goes in, that's brilliant. Whereas if we went in on foot to check it out, we would then leave a scent for ourselves. So we're not going to get rid of the dogs or remove feet from the ground. I think they all have a part to play. And when we start using all these assets alongside each other, that's when we really can reduce the time it takes us to find people, because that's what we're after, is finding people as quickly as possible.
Yeah, absolutely. And on the mission you mentioned today, is there anything else you can share about that, about how the drone was used at all?
So I can talk about the tactics used. I can't talk about the specifics, but in terms of how we search an area, we get a map at the beginning of a search. We'll have a zone. We'll go to this area. And what we do is, first thing we do is we fly the drone. We do all the safety checks and everything, but we go to the middle of the area. We do a quick 360, work out what's what and where things are. And then we'll basically do a perimeter search at about 40 or 60 meters, depending on what it is we're doing. Once we've done the perimeter search, we'll then search any sort of obstacles that are within that area. If there's a woodland, we'll go above the woodlands and basically have the camera pointing straight down, trying to look through the trees as much as possible, trying to find any heat sources. If we get the find, we radio in and a foot team will come straight to us. Quite often we are operating with the police. So having constant communications with them as well, because they may also have their national police helicopter in the sky as well. So just having communications with them. 9 times out of 10, if they've got an actual helicopter in the sky, we'll land and stay out the way. But there have been cases where we may need to be searching slightly different areas, half a mile away, and we'll all be in the sky together. But it's one of those that we have the communications direct with the police on that one.
Yeah, and then there you've got, I don't know if you've used them yet, but stuff like the beacon attachment.
Yes.
The spotlights. Have you had a chance to use any of those yet?
So we've used them all in training. We, as standard, during the day we fly with the beacon on. At night we fly with the spotlight as standard. We have played music through the speaker at 120 meters high, and you could hear it as crisp as anything. We've recorded audio clips and played them through the speaker, and I think everybody on the team was absolutely amazed about how good these attachments really are. You kind of read the sort of the sales pitch on it, and you think, well, of course they say they're that good. They're probably not that good, but when you get them and you fly them, we were just amazed about the quality of them. They really are great.
Yeah, definitely agreed on that one. Randall, before we move on to your presentation, have you got anything you want to ask Nick about any of their operations? Any questions at all?
I can't say that I have any directly. I think that things probably work the same way in the UK as they do in the US. And I think that the way that you structured that map of what is mountain land and what's lowland and cave rescue, I'm just wondering if if that's a pretty universal distinction, or if people kind of just do search and rescue, period, whether, wherever their territory is located. Because where I'm at in Salt Lake City, we have lowland desert, and we also have huge mountains. So I was just curious if maybe you know something about that.
No, so the ones on that map were pretty much the main bodies that everybody sort of heard of and knows. There will be some probably private search and rescue teams. There'll be urban search and rescue teams. There are slightly different deviations of it. The main one being that we are part of Lowland Rescue, which is its own sort of body as such. But there will be other private users of it and organizations. There's some of them are affiliated to Mountain Rescue, but they just have different lines of inquiry in how they do things, how they're called out, whether they're government funded or not, which I don't know of any that actually are. Say the police and fire do have their own drone teams. We work quite closely with them.
And being in the SAR space, are you finding that drones are particularly valuable in every aspect of rescue, or is mountain rescue using drones much more than lowland or anything like that?
I think Mountain Rescue moved into it maybe before we did. I think that came down more to funding. Mountain Rescue have quite a serious sort of funding behind them in terms of everybody knows them. A lot of people donate to Mountain Rescue. Not many people have really heard of Lowland Rescue. I hadn't really heard of it, and as soon as I had, I joined it. So I think that was one aspect. I think there was a lot of private members or private volunteers of Lowland Rescue that have their own private drones, and they've started using them as out on searches, which some teams allow, some teams don't. But for us as a team and the teams we work with, they're a complete no-brainer, and they are one of the best assets to have. As long as you can get the funding for you. Drones aren't cheap. We all know that. Anybody that's bought one knows that. You don't have to go straight to thermal drones. You can start with a standard Mavic, because sometimes all you need is a better idea of what's going on. If you use things like Google Earth, Bing Maps, that sort of thing, their maps can be a year old, 2 years old, and there's new roads, new housing estates, new golf courses. So actually just have an aerial view of that day is really, really handy for situational awareness.
Yeah, last question I would have is, you're talking about funding and how you get people to want to donate to purchase this technology. And I think that you mentioned that you had a rescue today or a save today. Is there a place that where all these search and rescue teams kind of come together and share their stories and maybe have a count of these saves, so that you could use that data to then go to people and say, look, collectively in the UK, we've saved 45 lives over the last 3 years or whatever? Or is it like news clip by news clip that they would find out that drones were used in these saves?
Yeah, so as an organisation, we have a committee, as a lot of volunteering organisations do, and they compile all of the statistics throughout the year for everything that we do and everything we achieve as individual teams and as a bigger body. There's various sort of Facebook groups and things like that. So I'm part of the, I think it's named as the Mountain Rescue Drone one on Facebook, which I get involved in as and when, particularly with sort of, that's where a lot of people share things. Internally as a team, we've got quite there's 4 or 5 of us that are constantly dropping good sort of data of statistics. But there are a lot of statistics on drone rescues. There's a lot in America, more in America than there does seem to be here. But the portfolio in the UK is definitely growing, which is great to see.
Yeah, people just get lost here a little bit more. You guys are better with your sense of direction. Those are jokes.
Definitely.
Might be. I think that's a good excuse to give. Right, Randall, do you want to run us through what you've got to present?
Yeah, sure.
And again, same thing, Nick. If you've got any questions along this side, obviously with it being thermal side, you guys just getting a drone with a thermal camera, I imagine you'll have some. This will raise some questions for you as well.
Yeah, so Nick mentioned that he just got called out and had some excuses. I did not get called out. I'm literally in my basement and knew I was doing this, but I never share video ever. That was like novelty back in COVID month 1 and month 2. And so you're getting a rare exclusive look of me not realizing I'm going to share a video and then sharing a video. So you're welcome. Also, is my screen, oh, never mind. The screen was flashing on my end, but I'm just going to run through kind of how we've been using thermal drone technology over the last little bit and just give you some examples of that. One interesting bit is that this will probably be my last presentation as Flir. Flir is getting acquired in 2 weeks from today by Teledyne. So you'll see Teledyne Flir become a thing. And that may open up a whole new world of drone experiences and payloads and things that we're going to do with unmanned technology. But just know that that's on the forefront of what's going to be happening. So this email, randall.warnas@flir.com, you could reach out to me if you have questions after the fact. It will likely be a different email in 2 weeks. Just a real quick rundown of myself. I've been in the drone industry for 7 years, started in pioneering drone retail, moved to DJI and started DJI Enterprise. And I was talking to a buddy this morning, and really the thermal imager defines what is an industrial drone versus a non-industrial drone. Pretty much every manufacturer is putting thermal in, and I can say that I was almost single-handedly instrumental in making that a thing, bringing thermal into the industrial world and democratizing the use of aerial thermal imaging. So that's kind of my claim to fame. I've seen a lot of stuff, done a lot of stuff, been working with Coptrz for probably 5-6 years, something like that. So yeah, happy to be here, happy to take part of this and give you guys some information. So I'm just going to run through these things, which is just kind of how thermal's used and different characteristics of thermal imaging that maybe if you're not using this technology, you might want to know. Nick mentioned that using a Mavic 2 Enterprise Dual with a 160 by 120 resolution camera is way different than using a 640 resolution camera, and I'm going to show a bit about that, some of the best practices, and we'll just go from there. So for those people that don't know what thermal imaging is, basically, rather than using visible light, you're using radiated energy that hits the camera lens and gives you an image. So you're basically looking for heat signatures that are in every existing object in the world. Because of that, you're able to do things like see in complete darkness. You're able to see through smoke and other obscurance. So it's really good for specifically search and rescue is amazing, an amazing use case for aerial thermal imaging. Also firefighting is also quite crucial, and we'll give some information about that shortly. But one of the largest things that make a thermal camera different than an RGB camera is the resolution. Rather than talking about 12 megapixel or 20 megapixel or higher visible light cameras, we're talking about pixels in the hundreds of thousands. So a 640 by 512 camera is considered high resolution. And here you can see there's around 327,000 pixels in that image. To get a good view of your target, you at least want to have 10 by 10 pixels of that image on your target. So there's a certain distance from the target that you can be with the resolution of your camera to be able to recognize and to clearly identify that subject. So I'm going to walk you through a little bit of that. Here is 2 images side by side with different resolution, 160 by 120, which is the Mavic 2 Enterprise Dual on the left, and a 640 by 512. This is at XT2 on the right. And you can just see the clarity and crispness and detail that you're getting with more pixels, but that should be pretty obvious. A couple of years ago, I did this kind of experiment, or just an illustration of how this technology is different when you change in altitude. So you have 160 by 120 on the left and a 640 by 512 on the right. And the subject in the middle is an 18-inch pizza pan. I guess that would be like, I don't even know. I don't even know what that is. And I guess you guys use inches. So 18-inch pizza pan, about 1.5 feet. And that's to illustrate roughly a person looking straight down on them, just to give us like a target size. So at 25 feet, you could see both images quite clearly. You wouldn't miss this target if it were there. If you were looking for a person, you'd be able to identify them quite clearly with either camera. But you could see things like the cracks in the pavement and a bunch more detail on the 640 by 512. But as you move up in altitude, now you're starting to see a much more blurred image with 160 by 120. And really the story I'm telling here is that you should never sacrifice resolution, especially when you're dealing with a human life. And you're at 50 feet. There are definitely trees in the British countryside that are taller than 50 feet. So you're often forced in search instances to fly much higher. So at 100 feet, if the person that you're looking to save is in the image on the left, you could easily pass over that, especially, this is in the middle of some cold concrete with nothing around it. But if you're looking through a wooded area, that's an area that you would miss. And the one, using drone technology is definitely speeding up search and rescue missions. It's proven, it's been done time and time again, and especially with K9 units combined, this is kind of like the dream team for search and rescue, is a drone and a K9 unit. But false negatives, where you think you flew over an area and you're certain that there was nothing there, so you tell your team to go look elsewhere, is probably the most dangerous thing for these people to have a successful rescue. So using low resolution at 100 feet even, you're really playing with a person's life. Or at 640 by 512, you're still able to see a significant amount of detail. And then I just jumped up to 400 feet, which I think is pretty consistent around the world as being kind of the ceiling of what you would fly in most missions. With the 160 by 120, can't see anything. You can't see the pizza pan that's heated up in the middle of the concrete, and you can't see where I am. In this image, you can see the pizza pan is here where my mouse is circling, and here's actually me standing in this yard. So just giving you an idea of what those resolutions do. And recently, Flir put out a product called the View TZ20, and this is at 250 feet, so pretty damn high. And here's at 1x, but what we've created is something that has thermal zoom, and it's not just digital zoom. It's actually jumping between a wide field of view and a narrow field of view camera. So you could take this 1x camera at 250 feet, where this is rarely, it's rarely this clear, but you're able to jump up to 5x, 10x, and 20x to really get a good idea of what you're looking at. And for search and rescue, to be able to instantaneously get closer to the subject without having to move the drone, without having to manipulate the airframe, and maybe in some cases you can't get closer, we feel like this is really the next big wave for what thermal imaging is going to look like in the unmanned space. It's too expensive and too heavy to actually build mechanical zoom onto thermal for a UAS platform. So we feel like this switch between different thermal sensors is really going to be seen on most of the thermal products that are put out into the future. I just wanted to illustrate another image here where this is at 400 feet and just showing the power of this zoom, where the subject is right here, where I'm circling on the 1x, and how you're able to really get down and detailed even at 400 feet. So field of view is another, hold on, I have to jump back and forward. Field of view is another issue that exists within the thermal space. In the past, you were dealing with a variety of different cameras. This was kind of trained into the Zenmuse XT2, where you were deciding what lens you wanted on those products. And basically you're sacrificing, as you get narrower in the field of view, you're losing the amount of space that you're covering at any given time. And with that zoom product we put out, you really don't have to choose one of the lens types, because you're getting both wide and narrow field of view. But with all the kind of new wave of products that are fixed into these Mavic-sized airframes, you're stuck with one lens type. So you're not making this decision. But if you wanted to do something like a utility inspection, or you wanted to get really close detail like this, you would have to fly quite close. And in some instances, that's dangerous or not possible. Generally, you're getting more of an image like this with those fixed cameras. Another important distinction between different thermal imaging cameras is whether you're doing qualitative or quantitative missions. You may have heard the term radiometric when it's dealing with thermal cameras, and really what that means is that when you capture an image with a radiometric camera, you're actually saving the temperature data for every pixel within that image. So then you could take it into a post-processing software and tune it so that you can really highlight areas that are exceeding certain temperature ranges. With things like search and rescue or firefighting, you don't really care what the actual absolute temperature is. You just want to notice temperature differences between the person you're looking for and the forest or the field around them, or the hot spot in the fire and the field around that hot spot that isn't burning. So most of these search and rescue, or most of these public safety missions, are going to fall under this qualitative framework, and so you don't necessarily need radiometry to do those missions. There's also different color palettes that Nick mentioned are available in most thermal imaging cameras, and I think that some people value the colorized images more because they think that it's more interesting to look at, or that they might see something jump out that they wouldn't see in either white hot or black hot. But white hot and black hot are the most standard color palettes for public safety missions. Maybe not firefighting so much because there's a huge range of temperatures in one image, but when you really want to have a target stick out, black hot and white hot and switching back and forth between them is kind of the best practice. You may look at this where black hot, everything that's the hottest is going to be black, and here white hot, everything that's the hottest is white. You may look at these and think they're just negatives of one another, but they're actually not. And the human eye allows itself to, if you flip back and forth between them, allows itself to notice differences in shades more easily when you're flipping back and forth than if you're looking at a uniform color palette for the entire mission. So again, for search and rescue, this is that color palette's really where you want to live. So here's a video of using isotherms, which is available on many thermal imaging products. And here are some best practices on how to set those isotherms. Basically, what isotherms are is you're setting a parameter within the camera to say anything that falls within this temperature range I want to highlight. And I apologize that these are in Fahrenheit, but basically you're saying that if I'm looking for a person, I want to see everything that's within plus minus 5% or 10% of what a person's temperature is, and it will be highlighted yellow like this. So you really take out the guessing of looking through a large area of land of what, if you did find your target, there wouldn't be a lot of guesswork to know that there's something there. The danger here is that maybe in the UK you don't have many days like this, but when the temperature of the ground is very similar to the temperature of the person, then you can have it be kind of all whitewashed out and you won't have this level of detail. This video specifically was done in Texas, but it was done in the colder months of the year, so a person stands out quite clearly. But in hot temperature, hot Texas summers, you really wouldn't use this isotherm feature, and maybe you wouldn't use thermal at all in some cases. For firefighting, you can clearly see that there's a fire. You don't need thermal imaging to tell that story, but aerial thermal imaging is used to identify hotspots as well as to use this technology to understand fires better and to train new recruits and even people that have been in the firefighting space for a long time. You're capturing imagery from a safe place without putting anybody in danger, and you're able to get real life scenarios that you could say, okay, how would you approach to fight this fire? What kind of machinery or equipment would be needed to do so? And it's much better to do these in real life instances than using controlled burn cases for that sort of training. This video is quite short, and I think that it's interesting. You can see this hot spot here. To the naked eye, this would be invisible. So now you know that the fire is spread into this room, and they could potentially go into this room and put out what might be a smaller fire and save all the property that's within that room just by looking at this. And like I was mentioning for training, what's happening is that they're cutting these ventilation holes in the roof, which allows the toxic gases to come up through the roof and more easily allow firefighters to go inside the building. And I've shown this video for quite a long time, and the feedback I get is that these firefighters are actually doing this wrong. You can see how hot this roof is here, and they don't have anything, like usually they'll put a ladder across the trusses so that if this roof falls in, that they have a stable place to stand. But they're basically operating on a roof that could cave in, maybe not at any moment, but it has that risk to cut these ventilation holes. And so again, having this kind of material to share and to say what's wrong here or what should someone do is really useful for people to get better at their craft. The last video on firefighting I'll show here is after a burn. You can fly above the building and look for hotspots. So here you could see that there's fire or heat that's still smoldering inside of the walls here. And if you had either the homeowner or the insurance adjuster or whoever going into this building, there is still a risk of reignition of the fire. And so to safely clear the building, you could fly a thermal drone above, look for these hotspots and clear them out. I think that this video is quite satisfying because it doesn't take maybe a genius to see that there's these things, especially because of this isotherm feature that they're using to show the hotspots. But once they use the hose, which he's using right now, to spray out that fire, you can clearly see that the issue is now handled. Search and rescue, we've been talking about it, but clearly is probably the most important use case for aerial thermal imaging. Both of these images on the right and left were real life search and rescue missions where they found their target. And it's just so compelling, even if you don't know whether this image was taken at noon or it was taken at midnight. And that's because thermal imaging doesn't care whether there's visible light available to you. So you're able to find subjects that could be missing and there's not a lot of light to guide them. And yeah, flying above the trees and above the terrain allows you to get there much more quickly. With search and rescue, it's hard to find really good imagery of it. So I take this video of howler monkeys that are in the forest in Costa Rica, and I'm trying to pause it. Hold on one second. And stop. Okay, so this was done in the middle of the day, and here's what you would see with an RGB camera. Nick was mentioning that even having a Mavic with without thermal is good. I agree, but in forested areas like this, where it's quite dense, you're not likely going to see a person stick out unless they're glowing or something. Where with thermal imaging, you're able to penetrate through the canopy of the trees, even thick trees, and see images like this, where this is probably a howler monkey a little bit below the foliage. These ones are maybe more towards the top, but clearly not towards the top where you can see them in the RGB image here. So this just gives you an idea of what looking for a person might look like, especially using an isotherm feature with a good amount of range between the temperature of your subject and the temperature of the surrounding area. So another area that's more, or I guess less commonly talked about in public safety is looking for hazardous gases. Flir has developed two products. One is for sniffing gases. So basically, here's a Matrice 210, has this long nozzle that is breathing in the air that's around it, and it can instantaneously give you, on your app, the levels of toxic gases or hazardous gases that are in the air. For hazmat groups or just public safety in general, they're using this technology already today to do that gas sniffing. And then there's also optical gas imaging, which is generally used for oil and gas applications, petrochemical companies that are looking for leaks. But if you have a turned over semi on the highway, or you have some sort of explosion or or threat because of that, you can fly in these optical gas imaging cameras, and you can see on the left side the RGB image doesn't show anything coming out of this flare stack. With optical gas imaging, you do get that, and this is different than just regular thermal imaging. It's tuned to find these differences in gases that are not solid, and so public safety entities are looking to kind of differentiate and diversify what their drones can do. They've bought the technology. They maybe have a RGB and a thermal camera, but there are ways to make this drone more applicable in different use cases based off of the different payloads that you put on it. And like I said, with Flir being acquired by Teledyne, which is about double the size of Flir, so it's not a massive company, but together we've been doing imaging for decades and decades, and there's a lot of things that we're going to learn as well as have access to in the future to really double down on the payload quality and payload diversity of what we're offering at Flir. And with that said, this is me. Again, email address should change pretty soon, but if you have any questions or if you want to talk after about anything specifically, I'm happy to help. Yeah. So that's it. I'll stop sharing and we can have a discussion for as long as people want to chat about public safety stuff.
Yeah, Randall, I mean, thanks a lot. I kept noting questions down as you were talking and then crossing them out because you answered every single one.
I've done it a few times, my friend.
Yeah, so I can tell you've refined it over a few years. You're an old hand. But I mean, I was going to ask about the TZ20 with the optical zoom or the dual lenses, but you covered that pretty well. There was a question on sort of the 10 by 10 effective pixels. So why it's that many pixels that you need to operate? Okay. And how much that's affected by going from say 640 down to 160 by 120. Is that 10 by 10 pixels just because that's from your experience what you've seen you need to have?
No, it's a pretty standard like confidence in thermal imaging. What happens is that let's imagine that I'm standing and you're looking straight down on me and the block of ice. If you have those things together, there's going to be some averaging of the temperature within the pixels between me and the block of ice. So if you only have 3 pixels on the image, 3 by 3, and they're a blend of something warm and something cold, it's going to average them out and it's not going to be as pronounced. It's not going to be as obvious. Where if you have 10 by 10 pixels, it's likely that, especially in the center, that there's not going to be any averaging out of colder things than the target that you're actually looking for. And so you asked if it's different between a 160 by 120 and a 640 by 512. Well, obviously, to get that 10 by 10 pixels, you need to be much, much closer with the fewer pixels that you have. And so it just allows you to have greater standoff distance to see more area and still have, that subject be obvious. For good temperature measurement, if you had, let's say, a handheld thermal camera and you're measuring something in front of you, you might want as much as 10 by 10, but you really can get a temperature measurement with 5 by 5 pixels. But that's from the air, especially looking down, there's a lot of movement, and so those pixels are constantly changing. If you're using a handheld, 5 by 5 is what you might hear. So
it's a pretty universally accepted 10 by 10 for aerial thermography. Yeah, makes sense. Then I'll look through some of the questions that have come in the chat. But while I'm doing that, Nick, is there anything you want to ask Randall? And I'll pull some questions while you're doing that.
It was the same sort of thing as you, Sam. I think he answered most of the ones I had as I was going. One thing I will say is that going through the different color ranges that you can have, seeing what you just did on your video, having the yellow element to the white hot one, I'm going to have to try and work that one out in a bit more detail, definitely. Today, particularly, I've noticed it was a warm day, it was sunny at times, but things were standing out quite nicely. But when we were looking at searchers that were searching, because they all had big coats on, big hats on, actually, unless you could see their face, it took a moment for things to warm up. But one of the really interesting things I found was when we were doing, in one of our training sessions, we were doing basically a game of hide and seek, is the best way to put it. One of our colleagues was hiding under a piece of corrugated iron. So when we searched it first, couldn't see him, but we spotted an object that we marked to say, right, we'll come back and just reassess that, because we looked on the RGB and saw that it was a bit of metal. Sure enough, about 5 minutes later, when we came back over it, the metal had actually heated up, so we could actually see a heat source coming from the metal. So then we could actually go and say, right, clearly there's something there. We can go and have a bit of a better look. So no, definitely the setting up different color ranges is something I'm going to have to, I think, just spend a bit of time on.
Yeah, just find the isotherm setting. Most of the drones have it. So the Boston Marathon bomber, maybe you remember this and maybe you've seen the story, but he was hiding underneath the cover of a boat and thinking that he was completely covered, but the helicopter had a Flir camera on it, and it basically showed in plain as day just his heat coming up through that cover. So yeah, but you're right. I mean, there's a certain level of time, an amount of time and amount of heat and the material that it's made of to let that heat penetrate through. But let's not confuse anyone that it's not like X-ray vision or anything like that. It really needs to penetrate through something. And so in this case, on that corrugated rooftop, they would have to be quite close to it, or there would have to be a significant difference in temperature from the surrounding environment.
Do you have any stats on how long it takes things to gain heat or lose heat? So at one of our training ones, someone they had a hat on. They'd had it on for about an hour. They put it on the floor, and it had a heat record for a little while, but eventually it disappeared. But I don't know whether it's the right thing or the right sort of industry to have those numbers. But
maybe the science from it could probably be done, but it would have to be and what the temperature around it is, and that's how heat is going to transfer. So I'm sure that there are some people that have worked that out, but or if a deer is laying in the grass for a couple hours and leaves, you'll see that temperature difference for Fahrenheit is what detected.
Losing your Randall,
that level of difference.
Just dropped off a little bit during that answer. I don't know if you can maybe run through that again, and we'll see if we can hear you again.
Can you hear me now?
Yeah, that seems to be a bit better. Yeah.
Okay. I don't know where you lost me, but I guess the main point I was making is it's 0.05 degrees Fahrenheit. So however that's transferred into Celsius, but 0.05 degrees is the temperature difference that a thermal camera can detect. So maybe your naked eye can't detect that, but the thermal imaging camera knows that there's a difference there, and that's where radiometry can be interesting. But to that minute sensitivity, if something has been in a place, like I was talking about a deer laying in grass, if it's been there for a while, it's probably going to be recognizable for at least an hour after that.
Perfect. Yeah, and one thing someone's asked during that conversation is there any thermography training available online? So I know that we do, as Coptrz, an intro to thermography course. There's also a Cat 1 certified course as well, which is like a full 5-day qualification, effectively. And there's tons of resource. I mean, personally, when I first started out, I watched a lot of what probably turned out to be Randall's videos on YouTube, a lot of stuff that Flir put out. And that's basically how I learned kind of basics of thermography for free. And then you can move on to doing the courses and stuff from there. But it is a whole, I think the takeaway from that is its whole own study and its whole own education. And it's not just as simple, and I'm sure, Nick, you found this, it's not just as simple as putting the drone up and flying it. There's a lot more you can do to take the quality of data from there's something hot over there to maybe take a look at, to being able to really pick out a lot of detail.
Yeah, because we've had it before where you pan across a field and you see something that's about 6 foot tall. You get there and it's a tree. It's a trunk of a tree. For some reason, it's showing a different color to everything around it. Whether that's a heat thing or it's just the signal it's giving off that's making it stand out. That's the sort of thing we need to get used to. At what point do we say, "Oh, clear, it's an oak tree"?
Yeah. Actually, do you want to know the reason that is?
Yes, please.
Yeah, go for it.
It's potentially two reasons, but it's definitely one of the two. It's either that the trunk of the tree has a different emissivity of the ground around it, and so it appears a different temperature because the camera is calculating emissivity, and it's saying if that thing is the same temperature as the ground, but it's made out of a different material, then it must be hotter. So that it's an emissivity problem, or the trunk of the tree has been absorbing water where the ground has not. The ground has been dried off, but maybe the way that the foliage hits or something, the trunk has remained moist. Then it could be a moisture issue as well.
So it's not just unique. There is a reason. There is a reason behind it.
Yeah.
Sure. I put a link to our Flir Delta page. For a long time, we were putting together videos like 3-minute videos that explain different principles of thermal imaging. I've put webinars up there that I've done on a bunch of different topics, like solar inspection, roof inspection, different public safety ones. And then there is also 28 episodes of podcasts that I've done with different CEOs or CTOs in the drone industry, talking more just about the industry. And it's been a while, so a lot of things have changed. But if you're wanting just a place to absorb a bunch of material generally related to aerial thermal imaging, you can visit that.
Perfect. And Randall, I think based on how thorough your presentation was, and also yours, Nick, we've already answered all the questions that have come in while we've presented. So there's not a huge amount now that normally we'd now fly through the questions. There's not that much to go through. I think what I'd like to do is get both of you, and this is what I like to ask towards the end of all of these, really, and we'll start with you, Nick, is if you could answer this, and it's a really tricky question to answer, so I appreciate you might not be able to give us a nice, concise one, but where do you see the future of drones specifically within your industry, within search and rescue? Where do you see it in, I don't know, 5-10 years time?
So at the moment we use drones to find people, and we aren't using them particularly within our team. Let's keep it to that sort of focus. We're not using them to get things to people. So when we find someone, what's the next step? Well, we call in a foot team, and the foot team go to them so that we can safely land the drone, pack up, and make sure the drone is safe. I would love to see that we can carry a payload. Once we get a find of someone, we can then fly next to them or near to them and then drop whatever they need. So if we have a search team that's a kilometre away, we can get to a point where this is taking away sort of the legislation side of it, but where we get to the point where we could basically stick a defibrillator to the drone, fly the drone to them, drop the defib there, or if they need oxygen or any other medical supplies. That's sort of where I'd love to get, to have the ability to drop something there. I think the priority for us is finding them. The next priority is treating them once we found them, and that would be a great place sort of for us to get to.
I don't think we're too far off that, are we? Really, I know there's a lot of trials and a lot of early stage proof of concept stuff around that, and I think from what I've heard anyway, it's more actually someone's just put it in the comments. It's more the policies, more the legislation holding it back rather than technology. And that was exactly what I was going to say until Andy there beat me to it. So yeah, I think you're right, and I think that could be sooner than we think.
Well, I think it was one of the conversations this morning, or it might have been yesterday, was a chap using drones to deliver things to Scottish Islands. And when you hear of it like that and you see what Amazon are planning, the technology is clearly there. It's clearly quite simple to do, in my opinion. It just comes down to the weights and what sort of weight you can put on them. But I'm sure the time will come when we can get the right licenses, we can go beyond visual line of sight, and we can sort of start pushing those boundaries. And I think legislation will catch up eventually. It really will.
Yeah, definitely. I mean, it has to. It just has to at some stage, doesn't it? So, Randall, same kind of question to you, or slightly different. So, especially with this Teledyne merger or takeover coming, where do you see the future for aerial thermography going? Again, sort of maybe 5-10 years. What do we think the landscape's going to look like?
Sure, but I'm going to take some liberties and not just talk about thermography, because thermography is a small slice. And actually, in 2015, when we first kind of introduced the democratization of aerial thermal imaging with the ZenMuse XT1, so many people were like, "What the hell do I do with this?" And it takes education. It takes a lot of work to convince people that this technology is doing something useful. Now it's a standard, right? And we're going to see more of those standards come forward. So in thermography, we're going to see more pixel counts. We're going to see 1,000 pixel cameras that are going to be relatively lightweight and relatively affordable. So size, weight, and power on the payload is going to be reduced. And then we'll see feature sets that are going to take a lot from autonomous driving vehicles, like human recognition, vehicle recognition, whatever, and it's going to classify things. So it's going to take less brain work from the operator, and they're just going to have to do these scans and wait until there's certain alerts or alarms that are going to be both on the temperature side, like this thing looks like it could be a person, and the shape of the image by using machine learning and things like that to tell us, when you might have found a hit for search and rescue. But on the just overall drone technology side, I think that there's going to be a big push for more autonomy, like Skydio is kind of leading the way of that. And DJI, as being the big company and all this, is going to see that and be like, nah, we don't get beat in anything. And so they're going to build a lot of autonomy stuff. And we're going to say, well, what do you do with that? I know that I can fly really fast through a forest, or I know that I'm not going to bump into things, but what can I do that I couldn't do before? What that's going to lead to is 3 years from now, we're going to be doing things like cave rescue. We're going to be clearing buildings with active shooters or active, hostage situations with drones more and more readily. You're seeing some of that stuff done with FPV drones, but that's going to be paving the way for those sort of things. We're going to see more beyond visual line of sight stuff happen, longer flight times, self-charging pads and networks, mesh networks of different drones, so it could keep persistent flight and you don't have to go back to change a battery. That's going to change. And I think that the last thing that I think the world's not ready for now is kind of these dock stations. So you'll have a drone that lives in a dock and it flies up and it conducts its mission and then comes back and self-charges. I think that that's the future. And if drone manufacturers aren't building that now, they're going to miss the wave of 2023, 2024, what people really want. But I think that when you see this technology today, it's going to be like thermal imaging was in 2015, where you're like, well, what the hell does one person do with that? What does Lowland Rescue do with a docked drone? But I think that we'll find organizations like yours, Nick, where you'll say, here's a heat map of where we do most of our rescue missions. And now we have the city or the state buy a drone that's going to live there forever. And so when someone reports an issue in that area, that drone already is trained to fly that mission without you having to respond directly, without, maybe it already has supplies that it can get to people. Maybe it has the megaphone that explains what direction they should be looking to the nearest road. I mean, there's a lot of things that could happen, but the drone industry requires us to be hungry and requires us to keep innovating, especially because DJI is so effing fast at doing it. And so we're all in the manufacturing world trying to find the next big thing, but we're always going to find it before the market's ready for it. So there's going to be an education of what this technology needs or can do or will do, and that's going to take probably 1.5 years to 2 years. We haven't found a way to make people absorb information faster, even though we've developed technology in a very rapid way.
Yeah, and when you mentioned, Randall, as well, the docking drone. I mean, for example, there's the Planck system, which you might have seen, which we're looking at bringing to the UK market specifically, initially for the MOD, but then, like all things, it cascades down from there into public safety and cascades down from there into the more commercial world, and so forth and so on. And I think that's a great way to round up, because, as you've said there, it's a wider range of use cases. It's more autonomy. It's less pilot interaction and involvement, and therefore the risk of things going wrong drops, the efficiency increases, costs decrease, amount of lives saved increases, all because the technology is all working towards the common goal. If there's nothing else,
one of the big things, just to jump in there, Sam, for us to search and rescue, every time a police helicopter takes off, it's £2,000-3,000.
Yeah,
we can get a drone out of our back of our van or the car or whatever, and it doesn't really cost anything once you've bought the drone. So in terms of 2 or 3 flights of a police helicopter, we've bought a drone. So
and
that's how the cost savings unreal.
And kind of like Randall was saying just then on the education side, if you tell that to a police officer 5-6 years ago, they wouldn't listen to you. And then there was a shift, a gradual shift, where you said, look, if you call that helicopter out twice, you could have bought a drone that you can use for 4 years, and you could save X amount. And you start to quantify it, and then they realize where they can be used. So yeah, the education side is a huge part of it. Any parting words from either of you? Anything else you want to bring up, or anything to finish on?
Just talking about the education side, I want to say thank you for giving us this forum and this place to educate, even if it's people that have been in this industry for a long time. Hopefully you've learned something, or at least it's an opportunity to get together, share ideas, get to know one another, and know that there's other people that are trying to just help and save lives and save property and bring this industry into, you know, another 10 years. So appreciate it.
Brilliant. Thanks, Randall.
Yeah, I'm not going to repeat what Randall's just said, but for anybody watching and listening, Sam's knowledge is phenomenal. He's helped us all the way through the process. When we had our fundraising project set up, I think he even put 20 quid in the pot. So yeah, if any of you have any questions, Sam really is a flipping knowledgeable guy when it comes to this side of things.
Hey Nick, do you have a website where you can make donations and stuff?
We do, yeah. We've got a Northamptonshire one, which I'll share now in the chat.
Please
if that's
do.
all right.
Yeah,
So we've got
to me, it's
Instagram,
all right.
Twitter, Facebook, all of that lot. So
I think I've seen in the chat that, Randall, you've shared some areas of the Flir website with training videos. Nick, you've shared there was a link there to all the Lowland SAR teams in the UK.
If you're looking for your local team, yeah,
local teams. So yeah, anyone further interested, obviously Nick and Randall's contact info you've seen. I'm sure everyone has mine as well. So depending on what you're after, please do get in touch. Any further questions you've not posted during this, feel free to fire them in now and we'll catch them afterwards, or send them in via an email, and I'm sure we'll get to them. But I think that's everything. So all that remains to be said, thanks so much for joining us, Nick and Randall. It's a bit of an unlikely pairing, but I think it's worked really well to have someone who makes the kit and then someone who uses the kit, and then be discussing it from both sides. Normally you only get one of those angles in these kind of webinars. So it's been nice to see it from either side. So to both of you, thanks very much for joining us. And thank you everyone that's tuned in for this for the final webinar of CoptrczCon. I think all we've got left now is the awards ceremony, which is kicking off in half an hour, is it? Half an hour. So that's the last thing we've got to do. So yeah, thank you very much for joining us, everyone. And I'm sure we'll see you shortly.
Brilliant. Cheers, guys. Thank you.
Thanks.